Okay, so this is the unit 4 linear functions quiz. We are going to take another one, so I wanted to go over this one because there was a lot of confusion on pretty much all of them. So let's get started with number 1. So when it comes to determining whether or not we have a function or not a function, it comes to a graph. The thing we do to it is to perform the vertical line test. So what we're going to do is we're going to draw lines through our graph. And you can also do this just by taking your pencil and going over it. But as you can see, we have an intersection point here and here on the same vertical line. Now, if it intersects at more than one place, just like this one intersects at 2 places, it is not a function. So therefore, this circle, number 1, is not a function. For number 2, we have a table. And when it comes to a table, the thing that we are looking at is the x values. And the trick that we learned is that with a function, the x values do not repeat. And when it comes to this one, we have -1 for x, -2 for x, -3 for x, and -4 for x. So the x values do not repeat. So although the y values are all 5, 5, 5, and 5, the y values are of no concern to us when it comes to determining whether or not something is a function. So since the x values do not repeat, this is a function. Now, for number 3, it is very similar to number 2. All we're going to look at here is an input and an output, and it's basically the input is the x's. So input is also another word for x, and output is also another word for y. And it's these x values, we have 0, 1, 2, and 3, going to different y values. Now, the dead giveaway for this one to not being a function is the fact that 0 is going to -2, and it's also going to 1. So therefore, if we were to write these as ordered pairs, we would have 0, -2, and 0, 1. And since the x values do repeat, this would not be a function. And another way I like to say this is this 0 is going to number -2's party, and it's also going to 1's party. And in reality, the same person, 0, cannot be at both -2 and 1's party at the same time. So as we move on to number 4, it once again is very similar to 2 and 3. What we're looking at here is whether or not the x values repeat. And when it comes to an ordered pair, please remember it's always x, y, x, y, x, y, x, y. So therefore 1, 2, 3, and 4 are my x values. And since none of them are repeating, yes, this would be a function. Now, the most confusion has come with questions 5 through 8. And for questions 5 through 8, the question is to find the slope for questions 5 through 8. So what this means is we are going to be finding m for every single one of these problems, but we're not always going to use this formula. So this is the slope formula, and we only use this when we are given 2 points, like number 7. So for number 5, in order to determine the slope, anytime we are given a graph, we have to remember that m is equal to rise over run. So what we are going to do is to rise and run from one point to the other, following these little paths along our graph here. So our first point is here. So we are going to rise 1. So therefore we're going to put a 1 on top. And we are going to run 1, 2, 3 to get to our next point. So since we ran 1, it goes on top because it's +1. And then we ran to the right 3. So we get a +3, and so therefore my slope is simply 1 over 3. Now, for number 6, it is pretty much the exact same way as the last one. The only difference on this one is we have to pick two good points before. So if we look back at number 5, it gave us a good point here and here. And what good points mean is you can see how they perfectly intersect the graph. So when we come over here, we have to find 2 points that perfectly intersect the graph, and one of those is going to be right there, and then there's another one right here. So what we are going to do now is to just do, just like we did over here, rise over run. So now, with this one, if we start from going left to right, we can run 1. So therefore, 1's going to go on the bottom, and we're going to have to go down 2. So since we go down, it's got to be a -2 because we are going down the y-axis. So it's got to be a negative. And then -2 over 1, if we were to reduce that, it would be -2. Now for number 7. Number 7 is when our slope formula that we see right up here up top is going to come into play. So anytime we are given 2 points, what we are going to do is, every single time, is we are going to label these 2 points. So this first ordered pair is going to be x1 and y1, and then our second one is going to be x2 and y2. So now, when we get x1 and y1 and x2 and y2, we are going to plug it into the slope formula. And the slope formula, which is up there, is y2 minus y1 all over x2 minus x1. And the cool thing about formulas is that they never change. So the hardest part is going to be recognizing what x1 and y1 are and x2 and y2 are and just plugging them into the correct spots. So our y2, if we go back up here and look, is going to be 5. So we're going to bring that 5 down, and then we are subtracting, because that's what our formula says to do. We are subtracting y1, which is -9. So we always plug in negative numbers with parentheses. Sorry, let's do that. And then we just got to do the bottom, which is our x2 minus x1. So our x2 is labeled here. It is 2 minus -2. So anytime we plug in a negative, we plug it in using parentheses. So then after we get to this point, the awesome thing about it is we can plug it straight into our calculator. So first things first, we're going to do alpha x, and then we are going to do 5 minus parentheses, -9 all over 2 minus parentheses -2. And then we just click enter, drag it back over, and our answer is going to be 7 over 2. So that's how you find slope given 2 points. Just please remember to identify your x1 and y1 and x2 and y2. That is something that not many people did, and I believe that's why a lot of people struggled plugging it into our formula. So now with number 8, I'm actually going to rewrite it over here and get it away from that. So it is y equals -x plus 2. And so the thing is with this one, anytime we are given slope-intercept form, and slope-intercept form is y equals mx plus b, I just like to play man-to-man defense. And what I mean by that is y goes to y. So y is y. M goes to the number in front of x. X goes to x, and b goes to b. Now, we are trying to identify the slope. And if you can't already tell, anytime we use slope, slope is represented by the variable m